You hear them outside in cars, they're in your home, and they're even in your computer. But what exactly is a motor, and how does it work? Another common place that you'll find an electromagnet and electromagnetism is in an electric motor. An electric motor is a device that changes electrical energy into mechanical energy or motion. It's actually the exact opposite of an electric generator. Electric motors are virtually everywhere that require electricity to move something. You hear that cooling fan in your computer? Yeah, that's a motor. You hear that motorcycle outside? You get it? Motor. Okay, let's build one. First, we'll make a solenoid. Then we'll remove the coating from only the top half of these wires. Next, I'll tape two needles together, and then take these needles and tape them to the ends of the battery with electrical tape. I will then secure this battery with the needles onto a lump of clay. Then I'll insert each end of the solenoid here through the needle eyes so that it's right in the center. Finally, I'll place a magnet on top here so that it's right under the solenoid. All I need now is to give it a little push, and there it goes. Notice how it's the wire now that's moving instead of the magnet from our electric generator. What kind of current do you think this is? Look at the power source. Is there any way we can affect the strength of this motor? Now, you might be asking yourself, why in the world did he remove the coating from only one side of the solenoid? Well, so it spins. When the coil starts moving, like poles repel it upward, and then the circuit breaks with the coating part, allowing us to use gravity to make it fall down to the other side, only to be repelled again when the circuit reopens. This creates a loop. And just like getting pushed on a swing, you don't have to be constantly pushed. We can let gravity help out a little bit. If the entire wire were exposed, opposite poles of the magnet and solenoid would eventually stick together, making the worst motor ever. Yeah, this is no good. So what if you wanted to build a better motor? What does that even mean? What are some questions you can ask about determining the strength of the electric motor and how to make it even better? Think about the electric and magnetic interactions, and I guarantee you'll come up with some great questions. But in science, there's only one way to find out.